Thanks very much for that introduction, and thank you also to the organising committee for inviting me to take part in this event. I'd say I'm really pleased to be here, but I'm not actually there. Instead, I'm coming to you live from Kyoto, where I'm at the Research Institute for Humanity and Nature on an AHRC fellowship at the moment. So I was especially pleased to be invited to take part in your festival because the topic of science fiction has an interesting relationship with bioethics. As a bioethicist, one of the things we sometimes get accused of is talking about technology that's just science fiction. But as Star Trek with its automatic doors shows us, today's science fiction is tomorrow's science. And what I'm going to talk about today was once the stuff of science fiction, but is now on the brink of becoming possible in fact. And as a result, we're facing questions about how we as a society deal with the possibilities of the future. The subject of my talk today, of course, is gene editing, which is something that's been very much in the headlines over the last year. While genetic modification is nothing new, and we've had techniques such as recombinant DNA technology for several decades, and some forms of gene editing technology such as zinc finger nucleases were developed some years ago, the technology that's attracted the most attention recently is the so-called CRISPR-Cas system, which was published at the end of 2012. And interest in gene editing, particularly its potential for use in human genetic modification, surged last year when, in April, a group of Chinese scientists published a paper reporting the experimental use of gene editing in human embryos. Around the same time, probably prompted by that research or rumours thereof, two separate groups of scientists in Science and Nature published commentaries calling for some form of moratorium on gene editing in embryos. And from this point onwards, gene editing was seldom out of the news. Various groups such as Funders of Bioscience in the UK, the Hingston Group, the National Academies of China, the US and the UK released policy statements about gene editing. George Church's group published a paper on gene editing pigs to create organs that would be safer for xenotransplantation. The first application to use gene editing in human embryos in the UK was submitted to our national regulator, the Human Fertilisation and Embryology Authority, and was approved just in February. And only last week, breaking news, a second study from China was published using human embryos in attempts to edit a gene that would be responsible for conferring immunity to HIV. The question that everyone's asking about these technologies, of course, is could we or should we use these techniques to modify the human genome? Would a future in which we undertook large-scale human germline genetic modification be a disease-free utopia or a eugenic dystopia? So what I'm going to talk about today is first to look at some examples of science fiction and genetics and to look at how we've used these examples to explore our concerns and our fears over genetic technologies. Then I'm going to run through briefly some of the ethical issues surrounding gene editing and look at how these have been dealt with within bioethics. And I'm going to move on to look at one particular issue of genetic enhancement. And at the end, I hope there will be a moral to the story, as there should be to all good stories. The work of fiction most often referred to in relation to genetic engineering, of course, is Huxley's Brave New World. But before that, and another metaphor that's often used in talking about new forms of technology, we had Frankenstein and his creature. Frankenstein and the Brave New World are often used as metaphors for manipulating or meddling with the stuff of life. They're cautionary tales that warn us of the hubris of attempting to play God or to interfere with the course of nature. But is that the job of science fiction, to scare us and to teach us not to mess around with things we don't understand? Or is there perhaps another role for science fiction, for flights of imagination and for stories that ask, what if? So is science fiction about fear, or is it about hope? Or is it perhaps a combination? Nowadays, when people think about genetic engineering, the science fiction work they often refer to is the film Gattaca. Now, Gattaca was released in 1997, and to give you a bit of context around this, the Human Genome Project was well underway, and the first complete human genome sequence would be published just a few years later. IVF had been developed 2 decades earlier, and pre-implantation genetic diagnosis within the previous decade, and Dolly the sheep was about to be born. Now, I don't know how many of you have seen Gattaca, but if you haven't, I recommend it. I think despite being 2 decades old, it's still very relevant to our concerns today. Gattaca imagines a world where everyone's fate is written in their genes. At birth, a baby's future prospects for health, employment and success are read out from their genome sequence. A job interview consists of nothing but a genetic test to make sure you have the right genes for the job. And in this world, it's usual for parents to select their children to have the best genetic chances in life. But Vincent, the main character in Gattaca, is conceived by accident, by chance rather than by design, and hence is born with a poor genetic hand that marks him as invalid, fit only for a job as a janitor, rather than pursuing his dream of becoming an astronaut. And the film then is about his struggle to overcome both the genetic odds and the much more significant barriers of a gene-obsessed society in order to realise his dream. As I say, the film is now almost 20 years old, but it still very much reflects some of the fears and concerns we have around genetic technologies and how they'll affect society. And in the meantime, some of the technologies it imagines have advanced closer to reality. I think it's worth pointing out that Gattaca is not really or not just about genetic modification. In fact, it's unclear whether the genetically advantaged valids in the film are engineered or just selected. But it is a story about genetic determinism and genetic discrimination. So Vincent's excluded from his career of choice because of nothing but his DNA. He has to assume a false identity in order to attain the genetic profile needed to achieve his goals. And some of the procedures he goes through are quite extreme. So he's 2 inches too short and has to have leg extending surgery to make himself taller. Now, for me, this raises quite an interesting question. Would it be better if he had had the option of being genetically modified rather than having leg extending surgery? I'm going to come back to that later. But what I want to do now is just run quickly through some of the main ethical arguments that tend to come up when we talk about human genetic modification and look at ways that we might analyse and respond to these. So the first of these is what we sometimes call the yuck factor argument. This is an argument from repugnance, the argument that says, well, it's just wrong. I just don't like it. And those of you who maybe work with genetic technologies, this is an argument that you may have heard when talking about your work. It makes people feel uncomfortable. It gives them a bit of a yuck response. Related to this is also the argument from naturalness. So this argument says, oh, it's unnatural. I don't like it because it's unnatural. Tampering with nature is somehow wrong, or maybe it's dangerous, which actually becomes a risk-based argument. So how can we address arguments such as this? Well, one way is to say that just because you don't like something, just because you find it repugnant, doesn't mean it's morally wrong. To give one example, we used to think that miscegenation, marriage between people of different races, was repugnant, but that doesn't make it morally wrong. A personal example, I happen to think bananas are repugnant. They are the fruit of all evil, but that doesn't make them morally bankrupt. As far as the argument from naturalness, we might say that nature's not a moral force. Nature just is. Existing genomes are just the product of random events that have shaped evolution. And we already intervene in nature in many ways. In fact, what is natural anyway? We are part of nature. Another argument that we might hear is that human germline genetic modification is playing God. So we're here talking about an improper exercise of agency. It's something we oughtn't to meddle with. There are definite shades of Frankenstein, the modern Prometheus here. So the argument is that tampering with things like the human genome somehow usurps the role of God. And we should note that this is often not a well-founded theological argument. This is often not made by people who are particularly religious. But what they're trying to say is that somehow it shows a lack of appropriate humility. So this is the argument about hubris. It's something we just shouldn't try to do. But why? What are the limits of proper agency, and why shouldn't we try to modify the human genome if we think there's some good to be achieved by it? We already engage in projects of creating life every time we set out to have children. And once we have children, we make choices that will affect their lives. So it's not really clear why genetic modification in particular should be singled out as an improper exercise of agency. Furthermore, why is humility the highest value? Should we ignore the suffering of others because of our humility? Should the doctor say, well, I think it would be playing God to perform this life-saving operation, so I'm just going to let you die. Sorry, I'm being humble. That doesn't seem like a very good argument to me. Yet another argument that we might confront is one that's based on what's sometimes called the sanctity of the genome. And this argument essentially boils down to saying there's an inherent moral proscription against modifying the human genome. There's something sacred about it. In early drafts of the UNESCO Declaration on Bioethics in the Human genome was referred to as the common heritage of humanity, and therefore something that shouldn't be interfered with. And a variation of this argument is to say that modifying the genome is a violation of human dignity. So there's something sort of sacred, special, essentially human about the genome that would be destroyed or damaged if we modified it. But we should ask what it is about the human genome in exactly its current state as it exists today that confers dignity. As I said earlier, the genome we possess has already been modified as a result of evolution. Mutation, changes to the somatic and to the germline genome occur naturally. And in fact, we're at liberty to make other sorts of changes to our bodies. I can dye my hair, I can exercise or neglect to exercise. So why can't we change our genes? They're just part of our physical makeup. Perhaps then it's the argument that it's too dangerous. So now we come to the risk-based arguments. And these are arguments that have been mentioned a lot recently with respect to the use of these techniques in humans. So the argument here is that genome editing is quite new. It hasn't been tested for clinical use and for reproductive use in humans. Therefore, something might go wrong. We don't know what. We don't know what the effects might be. So there's a risk of harm and there's uncertainty about what the harms might be. And the argument then says, well, because there are these risks, we shouldn't do it. Does that hold up? Well, someone always has to be first. With every new technology, there will always be risks, and someone will have to be the first to take them. Now, that doesn't mean that we should just rush in blindly and expose people to risks that we could mitigate, but at some point there will have to be small steps, always managed, of course, but small steps into the unknown. Furthermore, if we refuse to pursue any research because we think clinical application is too risky at this point, what we're doing is ensuring that application will always be too risky because we haven't done the research to find out what the risks are. So what we really need to do with respect to risk-based arguments is to weigh up the risks and the benefits, and this requires research. This requires scientific evaluation. Also, importantly, we have to realise that there may be opportunity costs of not doing research. So in the case of gene editing technologies that could perhaps provide cures or ameliorate serious disease, we have to weigh up the costs of what happens if we don't take any steps to treat that. How many people are we leaving to suffer? So the benefits may outweigh the possible harms. Refusing to act may actually result in greater harm. If we say we're not going to do any research into curing your condition in case something happens we never know what, then we're essentially condemning people to continue to suffer harm. And if harm is brought about by our failure to act, we're still morally responsible. If we see a child drowning in a pond and we do nothing, we are responsible for that death. If we see someone suffering from genetic disease and we say we could do research into how to cure you, but we're not going to, we're responsible for the suffering that then occurs. Okay, so perhaps what people are concerned about is not just modifying the genome and not just the risks to individual people, but the possibility of these changes, these modifications being passed on to future generations. So when we talk about human germline genetic modification, we're essentially talking about a problem either with performing interventions on or making genetic choices for those who are unable to choose for themselves, be they embryos or future people. And we're also concerned about affecting the genome of future generations. Now, why is that something we should be worried about? We've already dealt with this argument about the common heritage of humanity, and I don't think that really holds water. So when we say, what's the problem with genetic changes that might affect future generations, we're really actually talking about what I call an escalator effect. So the fact that it might affect future people as well as current people just makes any problems worse. So if we think that having no choice over your genetic heritage is a bad thing, more people are going to have no choice. If we think that there might be risks, the adverse effects are multiplied because they might affect more people. Okay, so choice over your genes and the risk of multiplying adverse effects. How do we assess these? Well, let's take first the argument about people having a choice over their genes. So the argument here goes that children or future people have some sort of a right to an unmodified genome. And the argument is usually that they don't have the ability to choose. So do we have a right to choose for them? Well, in response to that, I think it's fairly obvious that children never have a choice over the genes they are born with. You can complain to your parents afterwards, but there's not much you can do about it. And furthermore, choosing not to modify the genome is still a choice. Since we have to choose either way, to modify or not to modify, why not cure disease? I don't think our great-great-grandchildren will thank us if we say, well, we could have eradicated cancer and HIV and asthma and hay fever. That'd be a good one. We could have eradicated all these things, but we chose not to do it because you had the right to an unmodified genome. I don't think they'd really thank us for that. In fact, if the modification is beneficial, why wouldn't we want it to be passed on? So this brings us to the argument about adverse consequences and heritability. If an unexpected harm did occur, then it need not be passed on to future generations. So as I said, if it's a good thing, you probably do want to pass it on. But if something goes wrong somewhere, it doesn't have to be passed on. We could, depending on what the problem was, either have a future corrective modification to fix the problem, or those people who had been subject to the adverse consequences could choose not to reproduce. I needn't point out, I think, that this is already the choice that many people who are faced with serious genetic disease confront in deciding to have children. Do they risk passing on this genetic problem, or do they refrain from having children? So I can't really see that this makes the choice to modify any worse. Okay, a final argument, designer babies and slippery slopes. And this is one that's come up quite often, particularly with respect to the latest work about the research that's been done. And the problem here, the concern is that if we allowed germline modification to cure, let's say, really serious disease, it's going to be the first step on a slippery slope that will inevitably lead to designer babies, and people would be just going to the baby supermarket, ticking the characteristics they want, getting a printout, and then going home with their baby in a neat cardboard box. Okay, this seems like a bit of a ridiculous scenario, and I admit it's a caricature, but it's a genuine concern. How far could this go? Where should we draw the line, if you like? The thing we have to ask ourselves is, will we actually slip down the slippery slope? This area is highly regulated, at least in the UK. If you look at the regulations over the mitochondrial transfer therapy, there was an extensive public consultation, there was debate, there were several years, in fact, of talking about this, so it wasn't a decision made lightly. I think we can be at least hopeful that if we change the regulations eventually to allow germline modification using gene editing, that it's a step that won't be taken without considerable thought, without expert input, without consultation with the public. Furthermore, I think we need to ask whether slipping down the slope is always a bad thing. So views on what is acceptable change over time, and sometimes for the better. Someone might have said in the middle of the 1800s that abolishing slavery was the first step on a slippery slope at the bottom of which people of all races would be equal, would be allowed to own property, have jobs, not be subjected to racist abuse. And we might say, well, you know, the bottom of the slope there is not a bad place to be. So our views on what is acceptable can change over time, and that can be a good thing. Okay, so to sum up so far, I've presented some of the main ethical arguments that people often come up with against genetic modification, and I hope I've convinced you that there aren't any principled reasons, any intrinsic reasons against modifying the genome. While there may be concerns over risk and safety, our assessments of risk need to take into account the opportunity costs of not doing this work, as well as the possible consequences of doing it. And I hope I've also convinced you that there's no such thing as a right to an unmodified genome. That's something that just simply doesn't make sense. So, taking all that in mind, should we say yes to genome editing? Well, I don't think it is quite that simple. I want to look at one particular slope down which people are afraid that we might slip. And this is one that was pointed out by Edward Lanphier and his colleagues in the Nature commentary that called for a moratorium. So they said, we oppose germline modification on the grounds that permitting even unambiguously therapeutic interventions could start us down a path towards non-therapeutic genetic enhancement. We share these concerns. So their argument here is that germline therapy, let's say for serious diseases, is the first step on the slippery slope towards germline genetic enhancement. And what they imply here very strongly is that germline genetic enhancement would be wrong. So this brings us back to Gattaca and that point that I raised about having genetic enhancement rather than leg surgery. What's wrong with genetic enhancement? The prospect of using technologies, including genetic technologies, to make ourselves not just free from disease, but in Carl Elliott's words, better than well, raises many more thorny ethical questions than I have time to go into here, including what counts as disease, and where we should, if indeed we even can, draw a line between therapy and enhancement. But I'm just going to focus on one aspect of the argument about genetic enhancement, and that's to point out that we already use technology in all sorts of ways to make our lives better. So why not genetics? If I'm a struggling PhD student drinking 4 cans of Red Bull so I can get my lab work done, would it be better if I were able to have some sort of genetic modification so I could only sleep 4 hours a night and not risk caffeine overdose? So if we could use genetic enhancement rather than other means in order to achieve our goals, would there be something wrong in doing so? Well, genetic modification might well be less painful and less invasive than the leg-extending surgery that Vincent underwent in Gattaca. But I think we should also ask, what kind of world is it where we have to do this, where we have to be genetically enhanced in order to succeed? There's 2 ways of answering this. One's to say that elite athletes, musicians, top executives, top scientists already go to extreme lengths and make sacrifices in order to succeed. So why shouldn't we allow technology to help them? But we might also say, well, there's something wrong in seeing people's potential as limited by their genes. So enhancement shouldn't be a prerequisite for success. I think these views are not mutually exclusive. I think we can accept the use of technology to achieve our goals as well as resisting biological or genetic determinism. Maybe we shouldn't see people's options as being limited by their genes, but in cases where genetic conditions do place unwanted limitations on people's opportunities, wouldn't it be better if we could help people remove these limits? Even so, I think we need to ask ourselves whether it's genetics or society that imposes the limitations. Is it the capacities that we're born with, or is it how society treats us on the basis of our capacities, being a dog rather than a cat, for example? What is it that's limiting our opportunities? The problem may come when we start expecting or mandating the use of technology. So when does technology become no longer a choice? Well, of course, we don't really have a choice about the enhancement technology of literacy. We don't have a choice about learning to read or to use computers, for that matter. If we want to participate fully in society, these are things we have to do, like it or not. And what about vaccination? That's an enhancement of a form. It enhances our natural immunity. And there are countries where we are thinking about making this compulsory in order to receive other enhancements, such as education. I don't have time to go into those questions now because my time is nearly up, but just a few thoughts to conclude. We've looked today at some of the common objections to gene editing and some ethical arguments that we might make in response. But pitting philosophical arguments against arguments such as, I don't like it, or we have to draw the line somewhere, doesn't always work. Standard responses to this are, well, if you don't like it, don't do it. Why is that a reason I shouldn't do it? Or why do we have to draw a line, and why should we draw it there in particular? But I want to point out that that's not always what these arguments are saying. So sometimes they're not philosophical arguments. What they're saying is, I want a chance to talk about this. I feel my voice hasn't been heard. I feel I haven't thought about it enough. I want a chance to engage with the debate, to think about the science, to understand what's going on in my world. Now, I should point out that letting someone be heard doesn't mean we have to do what they say, but it's important at least to listen. And so this, I think, is part of the value of science fiction and of stories. They give us opportunities to engage with ideas in a relatively safe way, as imagination rather than as threatened reality. To ask the question, what if? And sometimes we might discover that the what if, the monster under the bed, isn't quite as terrifying as we thought it was. Thank you very much. And I would just like to thank the funders who've supported my work on gene editing and the AHRC who are supporting my research visit here today. Thank you very much.